Hello guys and welcome back to my channel Firewall Gyan. Today we are going to see what is DOS protection, zone protection, difference between DOS protection and zone protection, and what is Palo Alto encryption, decryption, and how the encryption and decryption profile are used. So let's begin. Let's understand if there is a given scenario to identify ways to mitigate resource exhaustion because of denial of service in application servers. Let's understand resource exhaustion. Port scan and floods are common cause of resource exhaustion at the interface and system level for protected device and the firewall interface themselves. Although Pan OS software does have powerful protection, none of them is turned on by default, which leaves a firewall exposed to these attacks until protections are configured. Palo Alto networks provide two protection mechanisms for resource exhaustion caused by attacks. 1. Zone protection profiles, and 2. DOS protection profile or profiles or policies. Let's understand zone protection profiles. Zone protection profiles depends the zone at the ingress edge against reconnaissance, port scan, and host sweeps attacks, IP packet based attacks, non-IP protocol attacks, and flood attacks by limiting the number of connections per second, CPS, or different packet types. Zone design itself provides segmentation of networks, which magnifies the protection of zone protection profiles. Zone protection profiles provide a broad defense of entire zone based on the aggregate traffic entering the zone, thus protecting against the flood attacks and undesirable packet type and options. Zone protection profile don't control traffic between zones, they control traffic only at the ingress zone. Zone protection profile don't consider individual IP address because they apply to the aggregate traffic entering the zone. DDoS protection policy rules define individually IP address in a zone. For example, this protection is done early in the traffic processing flow, thus minimize firewall resource to use. Less resources get used. Let's understand DOS protection profile. DOS protection profile and DOS protection profile rule combine to protect specific group of critical resources and individual critical resource against the session floods. Compared to the zone protection profile, which protect entire zone from flood attack, DOS protection provide granular defense for specific system, especially critical system that users access from the internet and often are attacked target, such as web servers and database servers. Apply both type of protection, because if you apply only zone protection profile, then the DOS attacks that target a particular system in the zone can succeed if the total CPS doesn't exceed the zone activate and maximum rates. DOS protection is resource intensive, so use it only for critical system, as is the case with zone protection profiles. DOS protection profile specify flood threshold. DOS protection profile rules determines the device, user, zone, and services to which DOS profiles apply. DOS protection profiles set the protection threshold to provide DOS protection against the flooding of a new session for IP floods, CPS limits, to provide resource protection, maximum concurrent session limit for specified endpoints and resources, and to configure whether the profile applies to the aggregate or classified traffic. DOS protection profile rules control where to apply DOS protection and which action to take when traffic matches the criteria defined in the rule. Unlike a zone protection profile, which protect only the ingress zone, DOS protection profile and profile rules can protect specific resources inside a zone and traffic flowing between the different endpoints and area. Unlike the case with the zone protection profile, which support only aggregate traffic, you can configure aggregate or classified DOS protection profile and policy rules. Between DOS protection and zone protection, a DOS protection profile can be used to accomplish some of the same things a zone protection profile does, but there is a few key differences. 1. A major difference is DOS profile can be classified or aggregate. Zone protection profiles are only aggregate. A classified profile allows the creation of threshold that applies to the single source IP. For example, a max session rate per IP can be created for all traffic matching the policy, then block that single IP address once the threshold is triggered. An aggregate profile allows the creation of max session rate for all packets matching the policy. The threshold applies to a new session rate for all combined. A trigger threshold would affect all traffic matching the policy. Zone protection profiles allow the use of flood protection and can protect against the port scanning and sweeps and packet-based attacks. A few examples are IP spoofing, fragments, overlapping segments, and reject TCP non-sync. Zone protection profile may have less performance impact because they are applied pre-session and don't engage the policy engine. Now let's move to the another topic, which is identify, decryption and deployment strategies. Let's start with the packet visibility. The use of encryption for all network application is growing at the rapid rate. When traffic is encrypted, the Palo Alto network firewall loses visibility into the packet contents, thus making content ID impossible. Because of this, malware might be able to pass unchallenged to an endpoints, at which point it is decrypted and able to attack. Decryption profiles maximize the firewall's visibility into packet content to allow the content inspection. Decryption. The secure socket layer SSL and the secure shell SSH encryption protocol secure traffic between two entities such as web server and client. SSL and SSH encapsulate traffic, encrypting data so that it is meaningless to entities other than the client and the server, with a certificate to affirm trust between the device and the key to decode the data. Decrypt SSL and SSH traffic to prevent malware concealed as encrypted traffic from being introduced into your network. For example, an attack compromises a website that uses SSL encryption. Employee visits that website and unknowingly download an exploit or a malware. The malware then uses the infected employee endpoints to move laterally through the network and compromise other systems. Prevent sensitive information from moving outside the network. Ensure the appropriate applications are running on a secure network. Selectively decrypt traffic. For example, create a decryption policy and profile to exclude traffic for financial or healthcare site from decryption. Palo Alto Network Firewall decryption is a policy based and can decrypt, inspect, and control inbound and outbound SSL and SSH connections. A decryption policy enables you to specify traffic to decrypt by destination, source, service, or URL category and block, restrict, or forward the specified traffic according to the security settings. In the associated decryption profile, a decryption profile controls SSL protocol certificate verification failure check to prevent traffic that uses weak algorithm or unsupported modes from accessing network. The firewall uses certificate and the key to decrypt traffic to plaintext, and then enforces app ID and security setting on a plaintext traffic, including decryption, antivirus, vulnerability, anti-spyware, URL filtering, wildfire, and file blocking profiles. After decrypting and inspecting traffic, the firewall re-encrypts the plaintext traffic as it exit the firewall to ensure privacy and security. The firewall provides three types of decryption policy rules: SSL forward proxy to control outbound SSL traffic, SSL inbound inspection to control inbound SSL traffic, SSH proxy to control tunnel SSH traffic. You can attach a decryption profile to policy rule to apply granular access setting to traffic, such as checks for server certificate, unsupported mode, and failures. SSL decryption, both forward proxy and inbound inspection, require certification or certificate to establish the firewall as a trusted third party and establish a third trust between a client and the server to secure SSL or TLS connection. You also use certificate when excluding servers from SSL decryption for technical reasons, the side break decryption, or reasons such as certificate pinning, unsupported cipher, or mutual authentication. SSL decryption does not require certificates. Let's understand what is decryption broker in a Palo Alto world. A firewall acting as a decryption broker uses dedicated decryption forwarding interface to send decryption traffic to security chain, a set of inline third-party security appliances for additional analysis. Two types of security chain network are supported with the decryption broker. Number one, layer 3 security chain and transparent bridge security chain. And you also can choose that the firewall direct traffic through the security chain unidirectionally or bidirectionally. A single firewall can distribute decrypted session amongst up to 64 security chains and can monitor security chain to ensure that they are effectively processing traffic. Let's understand decryption mirror. Palo Alto Network Firewall can automatically send a copy of decrypted traffic to a specified interface using the decryption mirroring feature. This option is available at no cost to middle and high-end firewalls that can automatically forward traffic of decrypted traffic to external DLP product. Let's understand keys and certificates. Palo Alto Network Firewall decrypt encrypted traffic by using key to transform strings, for example password and shared secret, from ciphertext to plaintext decryption, and from plaintext to the ciphertext re-encrypting traffic as exists the device. Certificates are used to establish the firewall as a trusted third party and create a secure connection. SSL decryption, both forward proxy and inbound connection, require certificate to establish a trust between the two entities to secure an SSL or TLS connection. Certificate also can be used when servers are excluded from SSL decryption. You can integrate a hardware security model HSM with a firewall to enable enhanced security for a private key use in SSL forward proxy and SSL inbound inspection decryption. Palo Alto Network Firewall decryption is policy based and can be used to decrypt, inspect and control both inbound and outbound SSL and SSH connections. Decryption policies allow you to specify traffic for decryption according to the destination, source or your category, and block or restrict specified traffic according to your security settings. The firewall uses certificate and a key to decrypt and decrypt the traffic specified by the firewall to plain text, and then enforce app ID and security setting on the plain traffic, including decryption, antivirus vulnerabilities, anti-spyware, URL filtering, file blocking profiles. After the traffic is decrypted and inspected on the firewall, the plain text traffic is re-encrypted as exists the firewall to ensure privacy and security. Central to this discussion is the role of digital certificate to secure SSL and SSH encrypted data. Your understanding of the role and the planning of the proper certificate need and deployment are important consideration in decryption use. The use of certificates is central to other important firewall function in addition to the decryption. Now let's understand decryption policies. Ingress traffic decryption is controlled by decryption policy. Palo Alto Network Firewall automatically will detect encrypted traffic and react by evaluating the decryption policies. If a matching policy is found, the firewall will attempt to decrypt the traffic according to the policy specified decryption action. Normal packet processing resumes afterward. Now let's understand SSL forward proxy. Decryption of outbound SSL traffic commonly is implemented and takes the form of SSL forward proxy, which features the firewall as an intermediate communication node. This deployment commonly is referred as a man in the middle. The following figure shows that communication like a man in the middle. If you see, the client initiates the SSL session with the server. The firewall intercepts the client SSL request. The firewall initiates SSL session with the server. The server sends a signed certificate to present. Server send a signed certificate to present to the client. The firewall sign a copy of the server certificate and send to the client for authentication. And the client verifies the certificate from the firewalls, and then the SSL tunnel are established between the client and the firewall and the server. The firewall decrypts the SSL traffic from the server into the clear text traffic and applies security policy to the traffic. The traffic is re-encrypted and pushed to the client. Note, the SSL forward proxy replaces the original certificate from the server with the signed by a different key that is delivered to the client. Now let's understand decryption exclusions. A developer of the solution using the SSL decryption can take extra programmatic step to interrogate the certificate received at the client for specific characteristics present in the original certificate. When these characteristics are not found, the author often assume that a decrypting process is in the middle of the conversation and may act to prevent full functionality and consider this presence a security risk. These products typically are not fully functional in a decrypting environment and must be added exception to decryption policy. Palo Alto Network recognize this fact and provide a mechanism to mark certain encrypted traffic for a decryption bypass. This matches in a part of Palo Alto Network for known pin traffic while allowing your administrator capability for a local. And last but not least, the app ID and encryption. The app ID scanning engine effectively often is compromised by encrypting traffic that prevents scanning packet content for identifying elements. This traffic typically is given the app ID of SSL. In some cases, the app ID engine can evaluate element of the certificate that secure this data for a specific identifying components, allowing the app ID engine to properly assign app ID without scanning contents, right? So I try to explain more of your zone protection profiles, DOS protection profiles, and encryption decryption of Palo Alto firewalls. If you like my video, please subscribe my channel and press bell icon so the latestly uploaded video will come to you as soon as I upload them. So guys, thanks for watching this video and have a wonderful day ahead. Bye bye.